Hello, everyone. This is the lecture for section 5.4, right triangle trigonometry. So in the last couple sections, what I've shown you guys is sine, cosine, and tangent. Well, we first started with angles, right? From angles, we define sine and cosine first, and then an extra one, tangent, right? I've shown you guys secant, cosecant, and cotangent, right? And I've sort of shown you mostly the theoretical stuff, right? This is where we actually get to apply the stuff, okay? It's going to happen right at the very end, okay? And it's really all that we really need for it, okay? So first of all, let me do a little bit of a review about sine, cosine, tangent, right? And we're going to go back to our triangle here, yeah? Um, if you remember what SOHCAHTOA stood for, right? If we have an angle T, right, then sine of my angle T, right, is opposite, right, over hypotenuse, right? Cosine, cosine of T, right, is adjacent over hypotenuse, okay? And then the tangent of some angle T, in this case, the one that's on the left there, right, is opposite over adjacent. Okay, this is what SOHCAHTOA stood for, right? Okay. Just keep this in mind because this is like basically all we need in order to start applying it to some real life stuff. Okay. All right. So just to get us some practice, right? For this angle or for this triangle, just give me sine of alpha, cosine of alpha, and tangent of alpha. I'm giving you what angle I'm wanting you to refer to. That one. Okay. So then for this one, right? Sine of alpha is sine is going to be opposite over hypotenuse, right? So it's going to be 8 over 15. Done. Okay. Cosine of my angle alpha, right, is going to be the adjacent over the hypotenuse. So 15 over 17. And look at me go. 8 over 17. Haha. And then tangent of my angle alpha, whoa, alpha, right, is opposite 8 over the adjacent 15. 8 over 15. Okay, that's it. Boom. We are all done. That's it. So this is just getting you guys a little bit more practice on it, okay? Quick checks. Do those in class, okay? Next one up. Cofunction identities and complementary angles, okay? So a fair amount of additional theory can come from just knowing complementary angles, okay? So two angles are complementary if they both add up to 90 degrees, right? Or if they both add up to pi over 2, okay? All right. So now, there are now a bunch of these 6 right here. They're called cofunctions identities, okay? And what these are essentially doing, right? It's grabbing any one of the original functions, right? It's grabbing cosine and turning them into sine. It's grabbing tangents and turning them into cotangents. It's grabbing secants and turning them into cosecants. Okay? Does that make sense? Okay, so to sort of show you guys how this works, right? It's really back to our triangle. It's this thing over here. Okay, so let me walk it through really quick so you guys can see what I'm talking about. Okay, so I'm gonna have 2 separate colors in this case. Okay, I'm gonna set them up right now. Okay, so for my angle alpha, right? My angle alpha, this is my opposite, and this is my adjacent, right? And this is going to be my hypotenuse, okay? For my angle beta, notice I'm changing the color here, okay? This is my opposite. This is my adjacent. and this is my hypotenuse. So thankfully, the hypotenuse is the same for both, okay? Now, take a look at this, right? That the sine of alpha is equivalent to the cosine of beta, okay? So sine of alpha, right, is going to be equal to opposite, right? It's going to be equal to the opposite divided by the hypotenuse, right? Opposite divided by hypotenuse, right? And then cosine of beta, right? The cosine of beta is, where am I? There we go. Cosine of beta is the adjacent over the hypotenuse, right? But look at this, right? Hopefully you guys see this already. The opposite for alpha is the adjacent for beta, right? So then that means that both of these were equal. And that's where we get that statement. Same idea goes for sine of beta is equal to cosine of alpha, okay? So what we can say now is this, that suppose, if you take a look at this, right? Let me get rid of all these highlights. Suppose we had this one, right? And we need to find this one, right? According to our thing here, right? If sine of t is equal to something, it is equal to that thing. So it turns out that cosine, right, of pi over 2 minus t will also be 5 over 12. Okay? Next step, right? For this one, if we have cosecant of t, right, of pi over 6, right, that is equivalent, right, to the secant of pi over 2 minus the pi over 6. That is secant of pi over 3. So we know that that's going to be 2 because that was equal to 2 to begin with. Whoa! There it is. Okay. All right. Let me actually highlight these in green so I can denote them as answers. All right. We're getting somewhere. We're getting somewhere. Okay. One last thing. Okay. Before we start doing applications of sine, cosine, and tangent. Okay. Last theoretical thing, right? And this is actually what we use. This is actually how we use trig in real life. Okay. At least without a scenario happening in the background, right? Okay. So before we start sticking in like real life stuff, let's work on just the triangle, just on its own. Okay. So I want to find the missing unknown sides. Okay. Okay. And the way that we're going to do this, right? Notice that in this case, I am given an angle and the side. I do not know these. I do not know what these are. Have no clue, right? But this is where we use trig. Okay, so now for C, let's go ahead and find the hypotenuse first. Okay. Suppose, right? We know from here, right? Sine of 30 degrees is opposite over hypotenuse. Correct? Okay. We know what our opposite is. Right? We know what our opposite is. Sine of 30 degrees, right, is 7 over hypotenuse. Okay? So then that means, right, if you do the arithmetic here correctly, my hypotenuse should be equal to 7 divided by the sine of 30 degrees. Okay, and from here, right, we know what sine of 30 degrees is, right? So hypotenuse is going to be equal to 7 divided by Sine of 30 degrees, if you go to unit circle, so hopefully you have that out, right, is going to be 1/2, right? And if you compute this out right, 14. We are done, at least with C. So we know that this is actually equal to 14. Okay? For side A, I'm going to use the trig that we have, right? Instead of using Pythagorean theorem. You can use Pythagorean theorem on this if you want, okay? But I'm going to use trig because that's what I want you guys to get comfortable with. Got it? Okay. So for A, for side A, for this side over here, right? That is the adjacent, right? And now we have the hypotenuse and the opposite, okay, to figure out our missing side, right? Uh, it doesn't matter which one you use, right? But hopefully you guys see that we need the adjacent, right? So that means we can use either cosine or tangent. Okay, so in this case, let's go ahead and be fancy with it. Let's do tangent. We know tangent of 30 degrees, right? That is opposite over adjacent, right? 30 degrees is equal to my opposite, 7, divided by my adjacent. Okay, so my adjacent side should be equal to 7 divided by tangent of 30 degrees. Now, tangent of 30 degrees. Tangent of 30 degrees. We know that tangent of 30 degrees, let me put it over here. Let's not do that yet. Tangent of 30 degrees, right, is sine of 30 degrees over cosine of 30 degrees. So I can grab my x and my y from my unit circle, right, and compute the thing out. So sine is going to be 1/2, and cosine is going to be √3/2. Okay, this is going to be equal to 1 over the square root of 3. We're not done yet. Okay, we needed to actually compute this thing out, right? So now we have a value here. Okay, adjacent. My adjacent side is going to be equal to 7 divided by 1 over the square root of 3. And that is 7 square root 3. We are done, if you do the arithmetic right. So this is how we use sine, cosine. This is how we use our trig in real life before we put, word problems in, okay? All right, next thing coming up, quick check. Okay, we'll try these. Now we get into the actual usefulness of our trig, okay? Now, this is very simplified, but it gets much more complicated in real life. I'm just starting it off really, really nice and low, okay? So, right, for example, let me actually open, I need Desmos open. There we go. Okay, I'll stick in Desmos in a second. Now, we use trig a lot. Actually, a lot of computers now sort of automate it, okay? But in order for us to automate that stuff, we needed to know what the heck we were doing to begin with, right? So here's sort of a pretty good example for it, okay? Now, I do have to warn everybody. Your calculator has different modes for computing trig. Got it? Okay. Please make sure you're in your correct mode. I got to state that to begin with. There are 2 modes. One mode is the radian mode, and the other is degree mode. Okay, it's basically telling the calculator what kind of angles you're putting in. That's it. That is it. Okay. All right. So let me do this example. Okay. So let's say I went for a hike the other day, right? And I wanted to find the height of a tree, right? So I walked 30 feet away from its base and measured an angle of 57 degrees from the ground to the top of the tree, okay? And I want to know what the tree's height is, okay? So in problems like this, right, the first thing that anybody will tell you to do is to draw a picture, okay? So here it is. Here's my picture. You guys can make fun of me as much as you want later. Here's my tree. Whoosh, right? Such a great tree. There we go. Woo! Look at that. Bam. Okay. So I went for a walk, right? And here's me over here. Yay. Okay. And from the ground, right, to the very top of the tree. You guys hopefully see my triangle there. I'm actually going to draw it in a nice little, the highlighter orange, at least a pen. There we go. Bam. Bam. There we go. Okay. This is a right angle, right? I measured my angle, this angle, to be 57 degrees. Okay. And I know that I walked 30 feet away. I need to know the height of the tree. I need to know this. I need to know what A is. Right? Actually, let me go back. I'm going to call this H instead. Okay. So hopefully you guys see what's going on here, right? I have an angle. I don't have its hypotenuse. I need to find the opposite, but I have the adjacent, right? So that should tick you off toward tangent. So I need tangent of 57 degrees. That's got to be equal to, right, opposite, so it's my H divided by my 30 degrees. Oh, sorry, 30 feet. Okay, so then that means H is going to be tangent of 30 degrees times, oops, blah, blah, blah. Look at me go, 57 degrees times 30 feet. Okay, and that is equal to, okay, this is now I'm going to show you guys what I mean by, oh, come on, there we go, by the different modes. I'm going to put that here. If you go into the wrench, okay, in Desmos, there are two options here. Right now it's in radians. I need to put it in degrees. Let me make that contrast a little higher. Okay, I need to put it in degrees since I am giving you guys the angle in degrees, right? Okay, and at this point, that's it. I can go ahead and type this in. So tangent of 57 degrees, notice it gives you the value, right? And because the mode is in degrees, I know that this means degrees, okay? Times 30. 46.19. 46.19 feet. Done. So, on my walk, on my hike, the height of this darn tree was about 46 feet tall. That's it. We're done. Okay? All right, some quick checks. These are going to be odd and even, okay? Try these out on your own for a little bit, okay? After that, lecture questions, okay? If you have any questions on the stuff that I covered, please ask me during our quick check time, or simply just come by my office hours or come to the tutoring lab. I'm there every day about, okay? Besides that, happy studying.